Hey guys, here's our last video. This is for the Unit 5 quiz review. We're doing area between curves and then volume by either cross sections or revolution. So this video is going to be specifically on the problems on the review about cross sections. So feel free to skip around through this video or skip around between videos. But hopefully you find it helpful. I'll see how much time I have. I'll try to get through at least one, maybe all three. We'll just see how it goes. So let's start with number 7. Number 7 says, let the base of a solid be the first quadrant region enclosed by y equals x squared and y equals 4. If all the cross sections perpendicular to the y-axis, that's key, are squares, find the volume of the solid. So the first thing I notice is this is a cross-section problem. Whenever I have a cross-section problem, I should always be thinking of taking the antiderivative of the cross-sectional area. Okay, so we're going to do the integral of A, where A is our area formula. Well, in this case, we're doing squares, and we'll come back to that in a minute. Let's see if we can just sketch a picture first. It says, let this be in the first quadrant region, so we know that's just first quadrant, enclosed by y equals x squared and y equals 4. So there's 4. This is going to be 2. So this is my region. My cross sections are perpendicular to the y-axis. And remember, this is going to be the bottom of a square, so it's coming up, out. Oh, that's really unclear the way this video works. It's coming out and making a square coming from each of these. We've got squares coming out of the page at us. So there's my picture. We've got our bounds. Remember, we're y-axis, so our bounds need to be y values. That means I'm starting at 0, and I'm going to 4. Okay, well now we're on to step 3. Step 3 is to figure out what my integrand is. Well, remember we're doing area, and this area is going to be a square, so it's going to be side squared. Well, remember this thing is going to be the base of the square. It's one of the sides, so if I can find a way to represent this, that's going to be S. So let's see if we can do that. Well, remember a distance is really a difference. We're going to subtract two things, the top minus the bottom. Well, let's see if we can do that. My top curve is this curve, because if I did a left-hand turn, this would be on top. This is y equals x squared. We need to solve for x because we're doing this with respect to y. So this curve is the square root of y. Minus this, well, this is x equals 0, right? So if I subtract a 0, that doesn't do anything, so that's s. So now I can set up my integral for volume. I'm going from y equals 0 to y equals 4. My area formula is something squared dy. Well, what's the length of the side? The length of the side is the square root of y. Okay? I could simplify this down to just being the integral from 0 to 4 of y, because the square root of y squared is going to be y. If you had to do this by hand without a calculator, that is something that we would assume that you could do by hand. So let's type this into our calculator. Let's do math 9. We're going from 0 to 4. I'm going to just type this in as y, which in this case is going to be x because of the way the calculator works, dx. And that gives me a nice, lovely answer of 8. There's no pi's, and this was a square. Okay, so don't tack on a pi there. See if we can do another one. It says, let the base of a solid be the circle x squared plus y squared equals 9. So the first thing I want to do is sketch my circle. Remember, this is r squared. So this is 3, this is 3, negative 3, negative 3. It says the cross sections perpendicular to the y-axis are equilateral triangles. So if I were actually to draw one of these coming up, I don't really love doing this, but there's these triangles coming up out of the page at us. So let's go through the same process that we did before. We need to start by finding our bounds. Because I'm doing everything perpendicular to the y-axis, that means I'm going to do everything with respect to y. So I'm going from negative. Okay, well now I need to do my area stuff. Well, hopefully, as I asked you to in class, you've memorized the area formula for an equilateral triangle. It's root 3 over 4 sides squared. But I still need to figure out what s is. Remember, s is the distance here, because this is the base or one of the sides of the equilateral triangle. So that's going to be my S. I need to do this minus this. Well, if I'm going to do that, I need to take my equation and rewrite this in terms of x. So I'm going to start by getting x squared on a side by itself. And then I'm going to take the square root. Well, remember, when I take the square root, I have, because this is x equals, I have two pieces. This side is the positive x's. So this is the square root of 9 minus y squared. This side is the negative x's. So it's negative the square root of 9 minus y squared. So remember, the s is the distance from here to here. Well, this side is represented by this. This side is represented by this. So s is the square root of 9 minus y squared minus a negative square root of 9 minus y squared. Well, that's really the same thing as adding them together. So s is 2 times the square root of 9 minus y squared. So now I can set up my integral for volume by cross sections. I'm going from -3 until 3. My formula for area is square root of 3 over 4 side squared dy. Okay, well, what is the side? The side is this. And that's what I'm going to type into my calculator. It's a little gross. There's some simplifying we could do. Like if I squared this, this would become 4 times just this. Actually, it simplifies kind of nicely because of this 4 down here. So if you wanted to simplify this a bit, you could, but I'm going to type that right into my calculator. I get a little bit crazy with parentheses sometimes just because I want to make sure that all came out clear. Times 2 square root of 9 minus x squared. And all of it. I think I should be in good shape. X. There we go. No pi's. We're just going to round to the 3 decimal places. You could leave this, again, you can round or truncate in calculus, so this would be the rounded answer, but if you were to truncate, you could also do 62.3 and you'd still be correct. Let's see what we got left. I think you guys should be in good shape to finish this last one now that we've done these two together. The last one's also perpendicular to the y-axis, so make sure everything's in terms of y. I hope you guys found that helpful. I'll see you guys soon for your quiz.